Have you ever noticed something strange? You open your phone, you search for a nearby cafe. Within seconds, a blue dot appears, perfectly centered on the map. It knows exactly where you are. Not just the city, not just the neighborhood, but the exact street. Sometimes even the exact side of the road. And for a brief moment, a quiet question forms in the back of your mind. How? How does something orbiting thousands of kilometers above Earth know where you are standing right now? Is it watching you? Is it tracking you? Or is something far more fascinating happening behind the scenes? Tonight, we are not exploring fear. We are uncovering science. Because the truth about satellites tracking you from space is not about secret cameras or hidden spies. It's about physics, precision, time, and one of the greatest engineering achievements in human history. This is the story of how space technology quietly guides your life every single day.
When you look up at the night sky, it feels peaceful, still, silent. But that silence is an illusion. Above your head right now, more than 8,000 active satellites orbit Earth. Some are the size of school buses. Some are no bigger than a microwave. Some are moving at over 28,000 kilometers per hour. They circle the planet constantly, day and night, in carefully calculated paths called orbits. These satellites are not randomly floating in space. They are positioned with precision. Each one has a purpose: communication, weather monitoring, Earth imaging, scientific research, navigation. And it is navigation satellites, specifically the Global Positioning System, or GPS, that allow your phone to know exactly where you are. But here is the first important truth. GPS satellites do not look at you. They do not see your face. They do not zoom into your window. They do something far more elegant. They send time.
At the heart of satellite tracking is something surprisingly simple: time. Every GPS satellite carries an atomic clock. These clocks are so accurate that they would lose only about 1 second in 100 million years. Think about that. Your watch might drift by a few seconds a month. These clocks measure time with mind-bending precision. Each satellite continuously broadcasts a signal that contains its exact location in space, the exact time the signal was sent. That signal travels at the speed of light, about 300,000 kilometers per second. When your phone receives that signal, it notes the exact time it arrived. By comparing the sent time and the received time, your device calculates how far away the satellite is. Distance equals speed of light times time delay. That's it. No cameras, no scanning beams, just mathematics. But here's where it becomes extraordinary. To know your exact location, your phone must connect to at least 4 satellites at once. Imagine you're standing in an open field. One satellite tells your phone, "You are somewhere 20,000 kilometers from me." That creates a massive, invisible sphere around the satellite. You could be anywhere on the surface of that sphere. A second satellite sends its signal. Now you are somewhere where 2 spheres intersect. A third satellite narrows it down further. A fourth refines it to a precise 3-dimensional point: latitude, longitude, and altitude. This process is called trilateration. It happens in milliseconds, quietly, constantly. And your phone performs these calculations again and again, updating your position in real time as you move. When you take a turn while driving, satellites are not following you. Your device is simply recalculating distances dozens of times per second. You are not being watched, you are being measured by time. Now let's address the question many people wonder about. Can satellites actually see you? The answer is more nuanced than most people expect. Some Earth observation satellites carry powerful cameras.
They can photograph cities, they can monitor forests, they can track storms. High-resolution commercial satellites today can see objects around 30 centimeters in size. That means they can identify cars, large equipment, road markings, but they cannot see your face. They cannot read your phone screen. They cannot look through your walls. Even the most advanced, publicly known imaging satellites are limited by physics, atmospheric distortion, orbital altitude, light conditions, and more importantly, satellite images are not live cinematic feeds. They are scheduled passes. A satellite may only pass over the same location once every few days. So the idea of a satellite continuously watching a single person is not scientifically realistic. But that does not mean satellites are not powerful. They are, just in different ways. Satellites save lives every day. Weather satellites track hurricanes as they form over oceans. They measure cloud temperature, wind speed, and moisture levels. Without them, storm warnings would come too late. Wildfire monitoring satellites detect heat signatures in remote forests before flames spread. They allow emergency teams to respond faster. Agricultural satellites monitor crop health. Environmental satellites track melting ice caps. The same technology that helps your phone find a restaurant also helps ships avoid storms and planes navigate safely. Satellite tracking is not just about you. It's about civilization functioning smoothly. And most of the time, you never even notice it.
Let's clear something up carefully and responsibly. Satellites do not know your name, your search history, your personal conversations, your thoughts. GPS satellites are passive broadcasters. They send signals outward. They do not receive personal data from your phone. Your phone listens. That's all. However, your phone apps can share your location with companies, but that happens through internet networks, not through GPS satellites directly. This is an important distinction. The satellite gives you coordinates. What apps do with those coordinates is a separate digital ecosystem. Understanding this difference removes unnecessary fear and replaces it with clarity.
You might be wondering, if this system relies on timing signals from space, how accurate can it be? Standard civilian GPS is accurate to about 3 to 5 meters, but with additional corrections, called differential GPS, accuracy can improve to within centimeters. Farmers use it to guide tractors in perfectly straight lines. Construction crews use it to measure land precisely. Scientists use it to monitor tectonic plate movement. Even tiny shifts in Earth's crust can be detected. That level of precision requires accounting for relativity, orbital drift, atmospheric delays. Yes, Einstein's theory of relativity must be applied for GPS to work correctly. Because satellites move so fast and experience weaker gravity than we do on Earth, time actually flows slightly differently for them. If engineers ignored relativity, GPS would drift by several kilometers per day. Think about that. Every time your phone shows your location correctly, it is quietly proving Einstein right. Many people assume GPS is the only system. In reality, there are several global navigation satellite systems: GPS, United States, GLONASS, Russia, Galileo, European Union, and BeiDou, China. Modern smartphones often connect to multiple systems simultaneously. This improves accuracy and reliability. The sky is filled with cooperative and parallel constellations of satellites, all working to provide positioning services worldwide. It is one of the few technologies where global competition has resulted in universal benefit. No matter where you live, these signals reach you, silently, constantly. Recently, another type of satellite has entered public conversation: communication mega-constellations like Starlink. These satellites provide internet access from space. Unlike GPS satellites, they actively send and receive data. They do not track your physical movement through imaging, but they enable global connectivity. Remote villages can access online education. Ships at sea can connect to the internet. Airplanes can stream real-time data. The sky is no longer just a place of stars. It is becoming an infrastructure layer of modern civilization, and we are only at the beginning.
There is something deeply emotional about this technology. Thousands of kilometers above Earth, machines built by human hands orbit endlessly. They survive extreme temperatures. They endure radiation. They move with astonishing precision, all to help someone on the ground find a road, navigate a city, call for help, reach home safely. When you watch the blue dot on your screen move as you walk, it is easy to forget the complexity behind it. But that tiny dot represents physics, engineering, mathematics, international cooperation, decades of research. It represents human curiosity reaching into space and bringing knowledge back down to Earth.
It is healthy to ask questions about technology. Privacy matters. Transparency matters. But fear often grows in the absence of understanding. Satellites do not secretly watch individuals through GPS signals. They do not read thoughts. They do not operate like science fiction surveillance machines. They operate through measurable physics. The real conversation about privacy belongs to data usage by apps, companies, and networks, not to the satellites themselves. Understanding this difference empowers you. Knowledge removes anxiety. Science replaces mystery with clarity. Right now, as you watch this, signals from space are passing through your body. You cannot feel them. You cannot see them, but they are there. Tiny pulses of time, traveling across vacuum, crossing continents, helping millions of people move through their day. The next time your phone finds your location instantly, pause for a moment. Look up. Somewhere above, a satellite is moving faster than a bullet, carrying an atomic clock, broadcasting a timestamp. And your device, in the palm of your hand, is decoding it in less than a second. That is not surveillance. That is science. That is precision. That is humanity extending its reach beyond Earth and gently guiding itself home. The sky is not watching you, it is helping you navigate. And the more we understand it, the less mysterious it becomes, and the more extraordinary it feels.